Write the binomial probability and the normal probability for the shaded region of the graph. Find the value of each probability and compare the results. We're going to do this manually, and we're also going to use technology, specifically Pearson's Statcrunch, which goes along with the textbook that we're using. So we want to look at the graph over here, and it's important to note that we're given the fact that n is 16 and p is 0.5, and this blue shaded region here is going to have a midpoint at 5, a midpoint at 6, and then a midpoint at 7, and that's what we're going to use when we start calculating the binomial probability. So, remembering that x is equal to 5, x is equal to 6, and x is equal to 7 are the midpoints of the rectangles, which means that the probability that x is between 5 and 7 is going to be equal to the probability that x is 5 plus the probability that x is 6 plus the probability that x is 7. And we could just simply write this as p of 5 plus p of 6 plus p of 7. And we're going to use the following formula for p of x. P of x is going to be equal to a combination of n items taken x at a time times the fact that we're going to multiply that by p to the x power times q to the n minus x power. Now over here we know that n is equal to 16 and p is equal to 0.5, which means that q is equal to 1 minus 0.5 because q is equal to 1 minus p. So in this case it happens to be 0.5. So down here for my p of 5, remembering that we're going to use n is equal to 16, p is equal to 0.5, q is equal to 0.5, and then x is going to be equal to 5, 6, and then 7. I know that I'm repeating myself, but I want to make sure that I impress upon you how important understanding where these numbers come from is. So, if n is equal to 16, this is going to be 16c, and x is going to be equal to 5 to start with, times p, which is 0.5, raised to the 5 power, and I'm going to use parentheses, times q, which is also 0.5, raised to the n minus x power, which is going to be 16 minus 5. Now I can simplify that and just simply write it as 16c5 times 0.5 to the 5 power times 0.5 to the 16 minus 5, which is going to be 11. Now, since these two bases are exactly the same, I could go ahead and add the two powers and have it as 0.5 to the 16 power, but I'm just going to leave it alone, and we're going to type this exactly into the calculator. Now, you have a combination key on most scientific calculators. Depends on where it is depends on what kind of calculator you have. So you need to be familiar with your calculator. So what I'm going to do is use an online calculator for this. So here's my calculator. It's web2.0calc.com. There's your URL right up there, and it's also right here. It's just a basic scientific, or actually it's a pretty good scientific calculator, and I'm going to be able to enter this particular expression exactly as it's written. Okay, so let's go ahead and get that back, and let's enter in our expression. Now remember, this is 16c5, so I'm going to use the combination key, which is this one right here, and I'm going to type it in as 16, 5, close parentheses. That's my combination, and you can see up here where I've just highlighted it, that's exactly what the combination formula is. and then I'm going to multiply that by, so we use the multiplication key, 0.5, and I'm going to go ahead and raise that to the 5th power. So I'm going to have to use my exponent key, 5, and then I'm going to multiply by 0.5. I'm going to raise that again to 11, and I'm going to press equals, and this is going to give me the probability of x is equal to 5. And that's going to be 0.0667. We want to do the same thing for P of 6 and P of 7. So this is going to be 16C6 times 0.5 to the 6th power times 0.5 to the 16 minus 6th power. And simplifying it looks just like this. And then I'm going to do the same thing for P of 7. Oops, that should be 7 right there, sorry. And we're going to go ahead and we will calculate that. I'm going to bring the calculator back in. We'll put it right there. We're going to go ahead, and this is one of the cool things about this calculator. If I left click over here with my expression, you'll notice that it gives me back the exact expression I entered. And now down here I can go ahead and enter in these new numbers. So this 5 is going to change to a 6. This 5 is going to change to a 6. And this 11 will change to a 10. I press equals, and I now have 0.1222. So let's write that down. And then we'll do the same thing for P of 7. So bring the calculator back, click this, change the 6 to a 7, change this 6 to a 7, change this 10 to a 9. And then I click equals, and I end up with 0.1746. Now remember though, I want to find P of 5 plus P of 6 plus P of 7, and so I simply add these three together, and we end up with 0.3635. Now, let's use Statcrunch to do this. Statcrunch is going to be an easy way of calculating the binomial probability. So let's bring that in. You'll log into Statcrunch through your problem. Once you're in there, you're going to hover over Stat, then hover over Calculators, and then you want to select Binomial. Now, this is a between situation because we're going from 5 right here to 7. So we want to make sure that between is selected. Let's go ahead and punch in 16 for n. We note that P is 0.5, so I'm going to leave that alone. But we're going from 5 to 7, and then I will click compute, and I get 0.3634. So it's a little off from what I got, but when I say that it's a little off, I got 0.3635, and Statcrunch got 0.3634. Close enough. Okay? So that's how we do that. And we're going to leave it as 0.3635, or, and I'm going to write that down, 0.3634.